Cool. Yeah. Hello, everyone. So I'm Webull. I did my PhD at Yale from 2011 to 2016. And then I joined Columbia as a computer science professor. And then meanwhile, I also co-founded CertiK, Web3 security startup. And we just finished our $2 billion valuation round last month. So we focus on protecting the smart contracts, blockchains, protocols, Web3 world, and the total assets we protected is about $300 billion. So I'm not sure if any of you knows what's the current coin market cap, total coin market cap today. Total, yeah. No, the entire market.
1.8 trillion.
Yeah, $1.7 trillion. So you can see that's a big portion. If we rule out Bitcoin, right, and Ether, so you can see our clients basically consists of a big portion of this market. So basically our company's valuation is less than 1% of the assets we protected. So our company is still pretty cheap. Okay. Yeah. So, but Bitcoin actually is a field, right, and products of the Bitcoin blockchain, right? So Bitcoin can understand as a cryptocurrency. Actually, it's also a distributed system, the blockchain system. Yeah. So Satoshi published this paper about Bitcoin in the year of 2008, and so from this paper we can get some keywords. So first is an electronic cash system, and it's trying to remove this trusted third party, and it's a peer-to-peer system, right? So first keyword is the electronic cash system, but we already have so many electronic cash systems. So why do we still need Bitcoin? Okay. So if we look at other electronic cash systems, we can find that they basically maintain a centralized ledger, right? Like banks, like PayPal, like Alipay, like WeChat Pay, right? So they maintain a centralized ledger, keep track of the, let's say, the account balance, the transactions of all the users, right? Like Alice and Bob, they have $20 and $10 in their bank account respectively, and then Alice sent $10 to Bob, Bob sent $5 to Alice. And then we know that after all these transactions, Alice owns $15, while Bob owns $15, right? That's an electronic centralized ledger system. And the limitations of this systems is that first, we need to trust this third party. We need to trust PayPal. We need to trust these banks and so on. And it's an opaque system. You don't know how these systems are managed underlying, and they are mutable in the sense that, let's say, if let's PayPal modify your account balance, how you can make a proof that, well, they make changes, how you can get your money back, right? These are the limitations of previous systems. So that's why Satoshi introduces Bitcoin, this blockchain technology is called decentralized ledger system, and it's a peer-to-peer system. And the underlying ledger will be the same, but we don't need to trust any third party, and it's a transparent system, and also
recording in progress.
Immutable, right? Okay, so basically blockchain is just this decentralized ledger, and a block is just one page of this decentralized ledger. Yeah, but then the question is, if we do not have this trusted third party, how we can decide who has a bookkeeping right, who will be the one that's manage these ledgers, the decentralized ledger, right? And this problem is what we call the consensus protocol problem, right? So there are several possible solutions, like we can randomly pick someone to do the bookkeeping, or we can do one person, one vote, right? Which is a normal way we reach consensus in the real world. And we can also base on stake, like most of the companies. Okay. Okay, then the question is, what is the consensus protocol used by Bitcoin? Any guess? It's random, or what? Based on stake, or one person, one vote?
Proof of work.
Proof of work. So what's the consensus protocol? How we decide who will have the bookkeeping right? Any guess? Among these three? Random? Yeah, some protocols use random. Any other ideas?
One person, one vote.
Yeah, actually it's one person, one vote, right? That's a consensus protocol used by Bitcoin. But then the question is how we can identify, well, you're a real person, right? So Satoshi made a small adjustment that they change it to one CPU, one vote, right? If you have one CPU, you can vote. And then how we can identify CPU, right? Using computation power, right? We'll give you some puzzle to compute, and if you have enough number of CPUs, you can compute this puzzle problems as faster, basically. So that's how we decide this one CPU, one vote. And this puzzle problem is like this. So let's say I'm Eve. I try to solve this problem. So I want to give myself some reward after solving it. So after mining, I get one Bitcoin, right? And in the year of 2008, I believe if you solve this problem, you'll get 50 Bitcoins. That's worth about what? More than $2 million nowadays, right? So, and this puzzle problem is to find an X, which is a nonce, such that if we use this data to compute a hash function, the result is less than some threshold. This hash function, you can view it as a random mapping function. Map a sequence of bytes into, let's say, some, in this case, it's 256 bits integer, right? So just trying to find this random X, trying to find this nonce to make the hash function results less than some threshold. And this is what we call proof of work, right? And this process is what we call mining. And assume, let's say, we're pretty lucky, we find this nonce 1, 2, 3, 4, 5, 6, 7, such that the hash value is less than the threshold. And then I will add this hashed value to this block, right? And this nonce is very hard to find, but very easy to check. And right, and we added this hash value to the block, and we also added the hash value of the previous block, right? So we use this hash value to link all these blocks together. So that's what we call a blockchain, right? Use it to link all the blocks together. And here, let's say, if two miners, they compute this final nonce, satisfy this requirements at the same time, and then how we decide which one is kind of like the real ledger, which one kind of like, they may be inconsistent, right? So we basically depends on the future miners, right? It depends on which path or they will choose to append the future blocks, right? Like if they choose to append blocks in the second branch, and then that one will be kind of like the I would say the major history. And usually when one branch is longer than any other branches in at least 6 blocks, we feel like, well, it's confirmed. So that's why if you make a Bitcoin transaction, you usually need to wait for 6 blocks time, which how long it take? 1 hour, right? 10 minutes for 1 block. And then the other branches will be abandoned. And it's called immutable because if we, let's say, try to modify the transaction history, then the hash value will become different. And then you can see that there's a broken in this chain. And the new chain will be shorter than the original chain and will not be adopted by other miners, right? So except for 51% attack, right? In the sense that if you get more than 51% of the computation power in the entire network, then you can make changes. You can keep, let's say, generating your own blocks until it's longer than the main branch, and then you change the history. So this 51% attack is an attack that can be performed to all the most of the blockchain system, I would say, and it just depends on the cost, right? And then we'll give you a bite size of smart contracts, right? So actually on top of blockchain, all the transactions are done using actually a program, a stack-based program. We call Bitcoin script, and it's very simple and it has less bugs, but it's very limited. The functionality it can support is very limited. So that's why Vitalik and the Ethereum Foundation, they create Ethereum, right? And is a Turing complete virtual machine. Basically means that all the programs you can read in your computers can run on all the computation platforms can also be executed on this virtual machine. Actually, it's not truly Turing complete because you still need gas, so it will terminate. And the programs run top of a blockchain are what we call smart contracts. So which basically encode the business logic into the program, right? Right on top of it. You can view it as a digital version of the contracts that we sign every day, right? In real world. And it's much more complex, but it also contains more bugs. So 6 years ago, right? There's a very famous attack called the DAO attack. And that attack basically leads to more than 3.6 million Ethers lost, which was about $10 billion nowadays. And it's caused by a re-entrance bug in a sense that, well, you can view it as smart contracts managed, let's say, everyone's bank accounts, and you can withdraw your money, all your balance, let's say, if your balance is larger, is positive, and you withdraw money, and then this contract will set your balance to be 0. But the thing is, right, you can see that we check the balance at the beginning, and then we let you withdraw, and then we modify clear your balance, right? So then the re-entrance attack will be conducted at this point. That's you pass the check, you withdraw the money, and then we'll re-enter this function and check that your balance is still positive, and you can withdraw money and keep doing, and you can repeatedly withdraw money and cause a big financial loss. And exactly today, this morning, if I remember correctly, there's another re-entrance bug and leads to a pretty big attack, leads to more than $18 million loss for fee protocol attack. You can see that people never learn, right? After 6 years, well, same kind of loopholes, it still leads to more than kind of like $80 million attack, right? So that's why we built CertiK, right? Our mission is to help prevent this kind of attacks and so on. So on the right-hand side, you can see that in the year of 2020, more than $500 million are lost due to software bugs in this blockchain Web3 space. Last year, this number is $1.3 billion. And this year, in the first 4 months, this number is $1.8 billion. You can see the the growth. So this is kind of like the major instance we summarized in April, right? And this month alone, we lost more than $400 million due to software bugs. And as Ridalio said that, cyber risk is a risk that he can't ignore to enter this Web3 and blockchain world. And that's messed up. So, I would say that Web3 security introduced lots of challenges that we have never seen in previous computation platforms. Like in Web2, in cloud computing, in mobiles, right? We use proactive ways to protect system. We try to identify malicious transaction, malicious access, right? And block them, right? As early as possible. Try to find the bugs in the system, add patches, and then redo the system. But we can't do it in blockchain world, in Web3 world, because blockchain is a world computer and no one can stop, right? Even if we identify malicious transactions and malicious access, we can't stop them. So we have to make sure that these programs are as secure as possible before the deployment. So previous security rates is not good enough. So we have to look at something new, like CPU hardware. CPU hardware actually is very secure. Its security rate can be something as good as 99.9% because they use a technology is what we call formal verification. We can prove that the implementation of the hardware, the software is 100% consistent with the design. So that's what we call formal verification. And however, in the year of 2016, right, the same year that the DAO attack happened, that's a report from National Science Foundation saying that formal reasoning about concurrency still in the early stages. So we can view CertiK as a combination of, let's say, this formal verification companies and the cybersecurity companies together, and we apply this technology in the blockchain and Web3 world, and we have secured more than $300 billion of crypto asset. We served more than 3,200 enterprise clients. Our security rate is higher than 99%, and our current market share is larger than 60%, according to the CoinMarketCap. That's the website you can visit. And so then we'll talk a little bit more about CertiK. So CertiK was founded in the year of 2018 by me and the other co-founder, who is Professor Zhong Xiao, the computer science department chair at Yale University. Yale University actually also one of the three founding entities for this business. And in the same year of the DAO attack, in the year of 2016, we created CertiK OS, the world's first and the only fully verified multiprocessor OS kernel. As Greg Morris, the dean of Cornell Tech, said that 10 years ago, no one thinking that we can verify multiprocessor OS kernel, but we made it. And it won lots of awards and was also deployed on this Landshark robotics, unmanned ground vehicle. And a red team from Google evaluated our system, and they use one word to describe CertiK OS. They call it unbreakable. And then we create an excellent team from academia and industry try to commercialize this technology. And right now we have more than 200 full-time team members, and we have offices across basically many countries. Yeah. And so here I give you some brief idea about our services. As I mentioned, so the first service is a pre-deployment auditing. And then we have a 24/7 monitoring system. It's called Skynet. And then we have our security leaderboard. Basically shows the security data of our clients to the public. You can't imagine that a Web2 security company, right, publish their client security data to the public, but we can't do it in Web3 because in this world, we want to make everything as transparent as possible. And we basically serve all the big clients in this space, like all these big exchanges like Binance, Coinbase are also our investors, and we serve all these big DeFi projects. And when we first sold the Sandbox, their valuation is just $60 million. Now it's a $5 billion company, and like ApeCoin, right? These very famous Ape profiles, they are all our clients. For auditing, so every month we provide more than 500 auditing reports, and we also bring in more than 200 new clients every month. So there are many other, so there are hundreds of Web3 security firms out there. So they can deliver about 10, 20 audit reports every month, we can deliver 500. And growing from 1020 to 500 actually is fundamentally different, right? Like to deliver 10 audit reports, you just need a 10 security expert, right? But what about 500 audit report? We don't have 500 Web3 security experts in the world right now. So we have to use other ways. So we build lots of tools to make this procedure as automated as possible. We even build, let's say, a monitoring system to monitor the quality of our auditors' work and so on. And we even build a monitor for these monitors and so on. So yeah, lots of work needs to be done to make this happen, to make this business scalable. And then for this Skynet system, so we monitored more than 4 billion on-chain transactions, and we also labeled more than 4 million accounts and addresses in this space. And we have more than 650 enterprise clients since its launch in the year 2021. And this is our security leaderboard. You can visit through CertiK.com website, and you can get the security insight, security data of our clients, and you can search it, and you can use it for you to do your own research before the investment. And then I show some of the data. Well, it's also messed up. So basically, from the CoinMarketCap, this website, you will find that, let's say, for the companies that have already purchased a third-party security service, our market share actually is above 70%, actually, 70%. But our absolute kind of like client ratio is just a 4.7%. In the sense that more than 90% of the Web3 companies, they haven't spent any single dollar in cyber defense. All right, so that's why we have seen this incidences happen again, and so on. So last year, so I count our revenue grew more than 13 times in a single year. So we finished, and we didn't actually, we just doubled our team size, and we finished our $2 billion valuation B3 rounds last month. And our investors include Insight Partners, Sequoia, TIGR, Coatue, Lightspeed, SoftBank, Hill House, Goldman Sachs, Coinbase, Binance, of course, Yale University. So I hope, I wish the best luck for your startup journey, and you can kind of like, if you need help, if you're Yale alumni, if you need help, you need suggestions. We also founded a pretty small early stage VC. It's about $45 million small VC. And if you need any help, just let us know. Feel free to drop us emails. And we're hiring as aggressively as possible. So if you want to enter space, right, and you don't want to enter very risky Web3 projects or company, you can join us. Yeah. Thanks.